The story you're about to see began in a cherry tree in 1899. A young man named Robert Goddard was cutting a dead branch when he stopped to admire the view of a meadow. Was it possible, he wondered, for a man to leave Earth and visit another planet? It was a simple question, but the answer will change the way we view our place in the universe. The study of the planets is centuries old. From the ancient Babylonians to Galileo and beyond, scientists tried to learn the rhythm of the universe. And where science left off, imagination filled the gap. English writer H.G. Wells' fantasy The War of the Worlds inspired a new generation of engineers, including an impressionable teenager from Massachusetts. Robert Hutchings Goddard was born in 1882. The son of a machine shop owner, Goddard learned to work with his hands at an early age. Although frequent illness kept him from school, he was an avid reader. Goddard's love of science and invention served him well, and within a few years' time, he had returned to formal academic study, earning a doctorate in physics by 1911. But Goddard never abandoned his childhood dream of visiting other planets, especially the red planet, Mars. For the dream to become a reality, the atmosphere of Earth must be breached, and for that, a rocket was needed. Creating such a device was not easy, and Goddard spent the next 15 years researching and securing finances. But in 1926, he finally succeeded in constructing and firing a liquid-fueled rocket. Goddard's research paralleled the work of Romanian scientist Erman Alber and Konstantin Tsiolkovsky of the Soviet Union. Collectively, these three men are often referred to as the fathers of modern space travel.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
Decades of research in the American space program reached a pinnacle in 1969 as Apollo 11 launched on July 16th. It was the first mission designed to place man on the moon, and it was a success. Over the next 3 years, astronauts conducted new missions to the lunar surface with an increasingly impressive payload of equipment. The images were stunning, but always the question remained, could we go even farther? Well, discovery must sometimes give way to safety, and the technology of the 1970s didn't allow for longer distance space travel, at least not for humans. So it was left up to unmanned spacecraft to explore the planets. From the Mariner series probes, which brought us images of Venus and Mercury, to the Voyager and Viking series, which photographed Jupiter, our window to the solar system expanded. But space exploration is about more than pretty pictures. Scientists wanted to know more about the structure of the planets, including their atmospheres. The Cassini-Huygens spacecraft was launched towards Saturn in 1997 with the capability of studying weather patterns. Although Saturn is quite different from Earth in size and structure, Cassini did detect a few similarities. For example, lightning flashes were captured, jet streams were uncovered. But the most intriguing images of all came in 2013. Images that prompted scientists to use a description thought to be unique to our planet: hurricane.
A hexagon is a shape that's fairly common in a child's playroom. Hexagons are not very common in astronomy, and yet there it is, a massive hexagon at the North Pole of Saturn. It was first detected by the Voyager series spacecraft in the 1980s, but the Cassini-Huygens craft produced higher quality images in recent years. The hexagon itself is essentially a collection of jet streams, or bands of fast-moving winds. We have jet streams here on Earth, but they tend to change position. The Saturn hexagon appears strangely persistent over time. Scientists with the University of Oxford attempted to model Saturn's wind patterns in the lab. By placing a spinning ring inside a rotating cylinder of water and varying the speed of spin, they were able to create a wide variety of shapes, even hexagons. So jet stream shape appears to be a function of difference in rotation between a planet and the jet itself. Researchers say hexagons may occur more often than we think in nature, even in hurricanes. They just dissipate so quickly they go unnoticed. And weather patterns do change quickly here on Earth. Many things can affect them, including friction from landforms. But on Saturn, there are no landforms, so storms can linger for decades. We find such a storm at the center of Saturn's hexagon. In 2013, Cassini-Huygens delivered striking images of a large rotating system. Researchers with the California Institute of Technology compared it to an earthly hurricane, but the scale is much different. The eye of the Saturn hurricane is about 1,250 miles in diameter, nearly 20 times larger than those on our planet. Winds are also much stronger, 330 miles per hour, nearly double those of a typical Category 5 hurricane on Earth. And the Saturn hurricane thrives on a planet with no ocean and very little water vapor in the atmosphere. It raised an obvious question: were there hurricanes on other planets?
Even before Robert Goddard climbed his tree and dreamed of visiting Mars, scientists wondered if the red planet could even support human life. In search of answers, NASA launched the Mars Pathfinder mission in December of 1996. The unmanned spacecraft consisted of a lander station and a lightweight robotic rover called Sojourner. The rover collected some rather provocative data on the red planet. Although Mars is essentially dry, Sojourner found evidence of a flood in ancient times. Where there is water, there is often life, and researchers sent 3 additional rovers over the next decade to investigate: Spirit, Opportunity, and most recently, Curiosity. Of all the rovers, Curiosity is by far the largest, roughly the size of a car. Still operational as of 2016, it continues to deliver scenes from the Martian surface, landscapes that appear alien and yet strangely familiar all the same. The Mars rover missions played a crucial role in the meteorology of the red planet. There are basically 2 schools of thought about the ancient weather history of Mars. Some evidence suggests the planet may have been much warmer and wetter, with lakes and perhaps even an ocean. Other models suggest a much colder, drier planet. In any case, Mars once had a dynamic atmosphere, perhaps supportive of more complex storm systems, maybe even tropical activity. But something happened to that atmosphere along the way. An event so catastrophic it altered the weather across the entire planet and made things much more complicated in the process. In 2010, NASA formally declared their intention to place a man on Mars by the 2030s. There was much to learn about the red planet before the final voyage could begin. The origin of the title Red Planet may date back to the ancient Egyptians, but it's easy to see why such a nickname exists. The red color of Mars comes from high concentrations of oxidized iron on the surface. It's natural for humans to associate the color red with heat, but Mars is actually quite cold and extremely dry. To maintain a planet's warmth, you need a thick atmosphere to act as a blanket. That blanket is protected by a natural shield known as the magnetosphere. But Mars doesn't have a global magnetic field, so over time the solar wind chipped away the atmosphere. Today, that atmosphere is extremely thin. So thin, in fact, that water has a hard time remaining stable in the liquid form. Hence, there is no ocean on Mars. And without an ocean, it would be pretty hard to form a hurricane. But that doesn't mean that humans are safe from the Martian weather.
You can learn a lot about a climate by studying the way people dress. The materials used, the size of the garment, and even the color all give clues to the prevailing weather conditions. To learn about the weather on Mars, look no further than NASA's new Z2 spacesuit. The sleek design may conjure images from science fiction, but the cover of the suit is all about safety. The thin Martian atmosphere offers very little protection from radiation, so an astronaut suit must provide adequate shielding. A thinner atmosphere also means colder temperatures, and Mars is located farther away from the sun than we are. The average surface temperature of the red planet is over 100 degrees colder than the Earth, but there are a few locations more temperate. In any case, an astronaut suit must provide warmth as well as proper oxygen balance. But surviving on the Martian surface is only part of the equation. Humans must first reach the red planet, and that takes time. Both Mars and Earth are in constant motion around the sun, so the distance between the planets changes. On closest approach, Earth is about 34 million miles from Mars. A journey of such scale is not fast or easy. According to NASA, a mission to Mars requires astronauts to be in interplanetary space for nearly a year and a half, even for a brief visit on the planet's surface. A longer duration mission could be up to 3 years. To learn more about what scientists would face, astronaut Scott Kelly spent a year in space aboard the International Space Station. He took a series of blood samples which were sent back to Earth and kept track of his body's dimensions. In space, gravitational effects are relaxed. This allows the disc of the spinal column to expand. During the year in space, Kelly grew about 2 inches taller. It's also not uncommon for changes in blood circulation to occur. This can cause swelling in the face and perhaps affect vision. Inner ear problems can occur, which can affect balance and lead to an occasional tumble. So when designing spacesuits for a mission to Mars, durability will be key.
Oh, you're absolutely right, Candace. The suit must also withstand abrasion from Martian dust. On a planet largely devoid of water, dust storms occur often. Sometimes they cover nearly the entire planet, accompanied by high winds and possibly lightning. But Mars also has smaller scale wind phenomena, including dancing dust devils, as seen in these ghostly images captured by the Mars rover Spirit. And just when we thought we'd seen it all, a startling image from the Hubble telescope challenged our perceptions all over again. On April 27, 1999, the Hubble Space Telescope captured an eerily familiar image on Mars, a picture that bore a striking resemblance to a hurricane. The swirling system measured roughly 1,000 miles in diameter. What's more, it had a cloud-free eye feature. Did tropical systems exist on Mars, in spite of evidence to the contrary? A closer examination revealed that the clouds were composed of water ice and located near the North Polar region. Scientists speculate the storm may have formed along an unstable front and strengthened in a zone of high temperature contrast. Equipment problems limited the amount of images captured, and the storm itself seemed to fade quickly. So the final analysis was largely incomplete. But the mere presence of the storm tells us that Mars still has a few mysteries. Even the winds are not what they appear to be on the red planet. It's important to remember that wind force is not just a function of wind speed. It's also a function of atmospheric density. And because the density of Martian air is only about 1% that of Earth, a 60-mile-per-hour wind on Mars would feel more like 6 miles an hour. It's ironic, isn't it? If you want to get more kick from the wind, look no farther than your own backyard.
Despite all the wonders of space, Earth is quite unique. It's the only planet with a surface covered mostly by water, about 70%. And yet the planet's most intelligent life form thrives on land, not sea. Land masses are critical to our planet's health. It's the uneven heating of various surfaces that drives pressure change, which in turn drives the winds, keeping our atmosphere in motion. The weather, as we commonly call it, provides nourishment for our crops and warmth for our bodies. But it can be deadly, especially when it comes to tropical systems. The Atlantic hurricane season runs from June through November. As monsoon thunderstorms roll off the African coast, warm water provides fuel for development. Thunderstorms grow vertically and air pressure is lowered near the surface. The Earth's counterclockwise movement combines with pressure gradient force to create a rotating system. When core winds reach 74 miles per hour, a hurricane is born. The center of the storm is called the eye. The weather inside it is relatively quiet. So why do we worry so much about the position of the eye? It's because the highest winds are usually wrapped around it in a region known as the eye wall. Even if the storm center is not forecast to hit your area directly, it's important to determine which side of the eye you fall on. For a storm approaching from the south, counterclockwise winds and forward motion provide an extra push of gusts and storm surge on the eastern side. On the western side, storm winds oppose forward motion, leading to less impact. In other words, the weather 50 miles to the east of the center is often much worse than the weather 50 miles to the west of it.
Ultimately, a storm's impact is a function of many factors. For example, consider movement. If the storm moves slowly, flooding rain becomes more of a threat. Consider topography. Storm surge potential depends greatly on the layout of the coastline. And remember, every landfalling hurricane presents some risk for tornadoes, especially in the right front quadrant. So what do you do if a storm threatens? If a hurricane watch is issued, it means hurricane force conditions are possible in 48 hours. You should have plenty of time to gather supplies. At some point during the storm, the power will likely fail. So don't forget flashlights and batteries. Make sure you have plenty of bottled water for drinking and bathing. Be sure to stock up on non-perishable food, fill any needed prescriptions before the storm hits, and know your local evacuation routes if you live near the coast. Naturally, you'll need a full tank of gas. Fill up before the storm strikes, since gas station pumps won't operate if the power goes out. And remember, credit card and ATM machines may be down after the storm hits as well, so keep emergency cash on hand. Of course, the best way to prepare for a storm is to know where it's headed. You can always see the latest WNCT 9 First Alert forecast on air, online, and with our First Alert mobile weather app. Track the storm's movement and follow the path with our team of meteorologists. We have 40 years of combined forecasting experience right here in eastern North Carolina. Sooner or later, another storm will head our way. It's our job to make sure you're ready.
Hurricanes have been called the great equalizers of our planet. Their power can humble even the strongest of nations. And while other planets have their own spinning systems, from the hexagon of Saturn to the polar swirls of Mars, nothing fully compares to the tropical systems of Earth. They are majestic, deadly, and always watching, it seems. May their gaze turn elsewhere this year. From all of us here at WNCT and the First Alert Weather Team, I'm Chief Meteorologist Jerry Jackson. Thank you for joining us.